Hello dear student, how are you? I hope you are all fine. Welcome to my channel. I am also fine. Thank you. Okay, let's start today's topic. Today we will be discuss some general technique, some general we will detail of some general organic chemistry, about reaction mechanism. We will study about reaction mechanism. There is many cases in the reaction where students get confused, like this is R, this is H double bond C, H, H. Let's suppose this is complex. If this compound is undergoes electrophilic addition reaction, means any electrophile add to the complex, what will be happen here? As only one case can be a student must be confused. This electrophile at this double bond, the electrophile attack on double bond, this is actually the attack of electrophilic, so this electrophile will attack on this double bond. But the arrow shows just it is just notation, it is just notation of electron transfer. Electron will be transferred from the pi bond, from the double bond to the electrophile, but actually electrophile will be attacked. So these are the electrophilic addition reaction. If electrophile are attacked, it will be like that, this species will be, this intermediate will be formed. See, this is H, this is R, this is H. So this type of intermediate will be formed. So in this case, the electrophile, mostly student confused that how, which bond we broke, which bond we break. You can break the bond, you will be break those bond, that bond in which the positive charge will go to those carbon that have more stability. If these are carbocation, you will be break that bond in which the carbon gets stability more as compared to if when the if the electron, if the positive charge go on the side. Like if you break the bond like that, then what will happen? Then it will be like that, that is Rc. Here is electrophile H, H, H. Here is plus charge, here is plus charge come. But it can also, you can take also the bond, you can also break the bond. Like if you break this bond, then what will happen? Then it will be like that, R C H. Here plus charge will become plus charge, so the electrophile will go here and H. So in this case, which here is plus charge, here is carbocation, here is carbocation. So now to see which carbocation is more stable, the carbocation that are more stable will be the product, will be the next step of this reaction, will be next step of this intermediate. So these are primary carbocation, these are secondary carbocation. Here is two carbon, one carbon, two carbon attached. Here is only one carbon attached to this carbon. While we know that the alkyl groups are electron donating group, these are electron donating groups, mean it will be decrease in case of more the electron donating group, it will be decrease the deficiency of electron. Here is the plus charge, means that there is deficiency of electron. So if there is more number of alkyl group attached, more electron donating group attached, it means that it will be the electron deficiency will be decreases, so it will be get stability, it will have not show much more reactivity toward coming nucleophile. Like in case of that carbocation, this carbocation will show more reactivity to the coming nucleophile, because this carbocation have only one nucleophile, has only one alkyl group, one electron donating group. That's why it have not enough stabilized. The electron will in this case, in the primary carbocation, here only one alkyl group electron donate to this carbon. It means that this is less stable, because here is more stability, because here is two alkyl group donate the electron, so it will get more stability. It have less deficiency, while it have more deficiency of electrons. At complete, it have less deficiency of electron. Well, here is more deficiency, so it will be show less reactivity, it will be show more reactivity, so this carbocation will be more stable, and the product of after that this carbocation will be found, the product will be like that. So that's why the coming nucleophile will be a take on this carbon as compared to this one. This is also the rule of this is also the rule of Markovnikov rule. It is also called Markovnikov rule. Markovnikov rule said that you will be add the electrophile to this carbon, in which the more the number of hydrogen attached. Yeah, these are the case of Markovnikov rule. But here is also we studied anti-Markovnikov rule. Anti-Markovnikov rule said that when the hydrogen come to this when electrophilic attack occur, the electrophile will be go to this carbon, to those carbon in which hydrogen is less, opposite to the Markovnikov rule, opposite to the, why will be happen this, if they in that case be in anti-Markovnikov rule be, we will be see the stability of the complex, that this in which in which position it get more stability. If there is, instead of alkyl group, if there is any electron withdrawing group attached, if there is any electron withdrawing group attached, like here is chlorine, then it will be like that, H H H electrophile plus charge. Then this bond will cannot be break, because if this bond will break to towards electrophile, then positive charge come here. Also we know that the chlorine is electron withdrawing group, at electron it make further deficiency of electron, which give the instability to the compound. While if this electrophile uh, if this bond break toward the electrophile, then positive charge will come to this carbon, this carbon will be more stable, because here is not enough deficiency of electron. But in case of here, if carbon is here, there will be electron withdrawing group attached, so here will be more deficiency of electron, so it will be more reactivity, it will show less reactivity, this show more stability, and this carbon will show less stability. So that's why the positive charge, the electrophile will be goes to those carbon having less number of hydrogen, will also called anti-Markovnikov rule, means Markovnikov rule will be failed here, while anti-Markovnikov rule will be followed. These are the general concepts of carbon hydrogen. These are the general concepts of RA. Mostly students are confused here in this reaction. So I hope you are will be very clear. Thank you. Okay, best of luck. If you have any confusion, you can ask me in comment section.